Hello everyone, we are Team 1 from G1501, Section 1, and we have made the COVID counter 9999. And we have 4 people on our team, and their names should be below. We don't have pictures, unfortunate. And it should be noted that the people who are speaking, they did their own narration, their own research, they did their own visuals. And without further ado, we're going to get started because we have a lot to go through.
So objectives for the design that we had was that it's sanitary and also that it limits employee to customer interaction to improve the safety of both the employee and the customer. Functions, we wanted to have it count the number of people entering and exiting the store and also ensuring that the store abides by social distancing guidelines and limits the amount of people in the store at one time. So it'll do that by counting. And then constraints, of course, were that it had to be less than $25, use the SparkFun kit, and in some way had to relate to like combating the COVID-19 pandemic. So the real problem statement that we came up with was that stores don't have a way of counting the number of individuals entering and exiting. That helps to limit their employees' exposure to the coronavirus disease.
After finding a prevalent problem on the streets of Boston, we used a decision matrix to decide between 4 possible solutions. The first solution we came up with was a contactless robot that counted people entering and exiting the store via swiping their hand through a slot. The robot would then let the customers know whether they were at maximum capacity or not. Another solution was for stores to give employees better PPE, such as a hazmat suit or layers of masks. Our third solution was a variation of the first, whereas if the maximum capacity was exceeded, the robot would chase customers out of the store. The final solution was for stores to upgrade their anti-theft sensors to include people counting capabilities as well. Right off the bat, we were able to eliminate the second and fourth solution, as it utilized the SparkFun Inventors Kit and would cost well over $25. And after considering our desired attributes of our product, such as profitability for the store, amount of human-to-human contact, ease of implementation, and amount of possible contact surfaces, and also how important these attributes were, we settled on our first idea.
There are 2 sets of code for the COVID counter 9999. For the entrance robot, it first sets up all the ports and all the variables, and then it calibrates and sets up the robot as well. Then it checks if the switch is on, and if the switch is on, it'll check if a hand has been swiped through the exit robot by seeing if any information has been received from the exit robot. After it does that, it'll check if a hand has been swiped through the entrance robot, and then it'll calculate the number of people in the store and let the user know if they can enter or not. The exit code is very similar to the entrance code. First, it sets up all the ports and variables, and it calibrates and sets up the robot in the same way as the entrance code does. Then it checks if a hand has been swiped through the robot, and then it'll send the number of swipes to the entrance robot. The entrance code starts by including all the necessary libraries needed to enable radio communication. Then it names all the different ports to the corresponding elements on the breadboard, and it also sets up the transceivers to communicate using this address. Down here, this just determines how often information is sent between the 2 radio modules. And in the setup, we start the radio communication. So once we get to the loop, there is first an if statement to check if the switch is on before we actually go into the code. After determining that it is on, then we start receiving information from the photoresistor. After it does that, it checks if somebody has exited the store using the information received from the exit robot, and then also updates the number of people accordingly. After it does that, it checks to see if somebody has entered the store, and this is done by checking if the light is darker than ambient light, and this is determined in the setup function. And this means that there's a hand present, and if there is, then it increases the number of people in the store by 1. If the number of people in the store is less than maximum capacity, the RGB LED will turn green to signal that it is okay for the user to enter. But if the number of people in the store is greater than maximum capacity, then the RGB LED will turn red. And down here we have in greater detail some functions that we used in our code. Get data and show data are pretty self-explanatory, but in sensor setup, this is where we find out what ambient light is. And how this is done is that we turn on the sensor LED and wait 10 seconds while collecting data. And with all the data we collect over the 10 seconds, we average this, and this becomes our ambient light value. The exit code is pretty similar to the entrance code. Again, here in the beginning, we include all necessary libraries. We also set up all the ports and name the variables. And again, we create this slave address to communicate with the other radio. And here in the setup, we begin communication with the other radio. Once we get to the loop, the code is much more simple than the entrance code, since there's no warning LED to turn on or off. So here, it first turns the sensor LED on, and we start receiving information from the photoresistor again. So the robot determines if there's a hand in the way it's the same way as before. It checks if the current light is darker or the same as ambient light. And if it is darker, then this is a hand blocking the light, and it'll increase the number of people counted by 1. And then after that, it will send the information to the other radio. And down here, we just have the function for sending data. So it's just one function in the radio library, and we just have some serial prints just to monitor to make sure everything's actually sending perfectly. And here we have the same sensor setup function as we do in the entrance code. It will average the value of the photoresistor for 10 seconds to find what ambient light is.
So as you see this very nice panning motion from the camera, you can see the standoffs and the LED and the photoresistor, and we're actually going to freeze frame right here. Alright, so now we can label things. The photoresistor is at the very top, the LEDs at the very bottom. You can see the acrylic plates. The standoffs at the bottom are 1 1/4 inch. The Arduino is at the very bottom. It's connected to the NRF24L01 modules by the male to female jumper wires. And we're gonna switch to another clip right here. And you should see, we're gonna freeze frame again right here. And you should see the backside, all the guts of the whole thing. And you have the breadboard, you have the connections, you can see the RGB highlighted right here. Same thing going on with the NRF24L01, which I'm going to highlight again. It's this little plate thing sticking out the side. And we have the battery pack on the bottom, the breadboard on the left, breadboard on the right, and then we have all these wires going every which way. And it's a giant mess, so we're not going to highlight any of those. We do have some resistors, although they are already highlighted in the TinkerCAD. It's pretty obvious. And then you can see here, because of the design restraints, particularly from the enclosure, we weren't actually able to wire a lot of things like they were in the TinkerCAD. It doesn't actually matter, they just changed spots, so maybe row 1 went to row 4 instead. It's not that big of a deal. So we're gonna switch right now to another clip where we're just gonna demo how it's working. Yeah, someone swipes their hand through and it counts, lights up green. Once you count enough times, it's gonna light up red. And that's basically the whole thing until someone else swipes out at the exit, then someone can enter at the entrance again. Of course, this is prone to abuse, but we live in a perfect world. So the TinkerCAD is only really important for documentation purposes and for other people who would like to replicate this design. This TinkerCAD actually uses a stand-in for the radio module that we have. We put in another module that also had 8 pins, but we just mocked it up. And that's about all there is to the TinkerCAD. Feel free to freeze frame this frame if you want to reconstruct it yourself. Alright, so this here's the bill of materials, or as we call it for short, the BOM. And we only really had 2 purchased components. The clear acrylic, which we bought 2 sheets of, and the transceiver module, which we bought 4 of, but used 2. And I'm actually using the other 2 in a project, so we only counted 2. We got one from Amazon, the other one from the bookstore, and that means there were no shipping costs because I have Amazon Prime. And the other pieces were either from the SparkFun kit, like these, or Filec, and we borrowed some hot glue from Megan's roommate. Shipping was null, and there were no labor costs, which was rather unfortunate, I guess, for the workers, but that's how it be. So this project didn't actually achieve much beyond what can only be called a proof of concept. It's not even really a product. So there is much to be improved upon in design and on the software side, and the wireless communication and sensor calibration can both be fine-tuned to work even better. So we're going to get started on future improvements. So the radio module, the NRF24L01, can be connected to more modules, which would necessitate the need for syncing up their transmissions so as not to corrupt any data. The first improvement derived from this would really just be another module that could monitor the total number of customers in the store at a given time, display that on an LCD screen for the manager, and have buttons to lower or increase the maximum capacity. So think of it as a very fancy remote control. On the programming end, the sensor setup could be improved, and although I had started on a program that used standard deviation to create a buffer on the photoresistor threshold, which would protect against false positives from shadows, it was abandoned due to time constraints, which were exacerbated by operational deficiencies, which will be further explained below. The enclosure design can be drastically improved as the laser cut pieces did not actually enclose the Arduino properly, nor did it have the capability to redirect wires. And unfortunately, this is really just linked to operational deficiencies as the person assigned to the enclosure was overseas, and therefore communication was done in 12-hour increments. And there really wasn't much we could do about that, and working in 12-hour increments is nearly impossible, and we all lead very busy lives. So personally, I have club meetings 3 to 4 days a week each evening, which is our ideal meeting time because our member overseas also has meetings during her days. And then our other 2 members also have their own things, which means that we effectively have very low odds of our schedules overlapping. And then that has led to some very odd meeting times, like 10 p.m. Adding on the time constraints, our overloaded team members who were on campus didn't really have time to properly review the AutoCAD files. So as a result, the enclosure was kind of just MacGyvered, and we put drills and standoffs outside of the original design. The one biggest challenge was really just doing the work, and it sounds silly, but we did have a project management plan going into this, which quickly turned into straight up damage control. Everything just was on fire. And of course, tech was going to malfunction, and things were going to go wrong, but the biggest failure was in how these responsibilities really just fell on 2 people who were on campus, and that led to the current result, because of course we have that one member who's 12 hours away, and there is no way she is going to fly over here just to work on this project. But that's it from us. Enjoy your holidays. And that's it.